Hi everyone and welcome back. It's Kira Garfolo with Greenville Tech Math-155. Today we're going to talk about section 4.4, which is about area. So just as an overview for what we're going to be doing when we calculate area, you need to remember that the area of a figure always comes from multiplying together two different distances. Okay, so we're multiplying. Unlike in the last section where we talked about length, and perimeter. Remember, with perimeter, we were just adding the edges. With area, we're going to be multiplying, okay? And for this reason, your final units for area calculations will always be in square units or in units squared, okay? So units squared or square units, it might be something like inches squared or centimeters squared, something like that. But it's because you're going to be multiplying inches by inches to get squared inches, okay? One very, very important thing to do, we saw this with perimeter also, is to make sure that all of your measurements are in the same units before you proceed. If you don't do that, we can't backtrack and fix it very easily. So make all of your conversions before you apply a formula. It can also help to read the question fully, because just because you would switch it all into one certain unit, maybe you'd go to meters, the problem may ask for centimeters. Okay, so just be very careful and be cognizant of that as you proceed. So let's dive right in and talk about the area of a parallelogram. So for the area of any parallelogram, so remember that a parallelogram is just a quadrilateral where the opposite sides are parallel to each other. So this includes squares, it includes rectangles, it includes rhombuses, all of that stuff, okay? But to find the area of a parallelogram, you are going to multiply the length of the base times the height. Now be very careful here. The height must be the vertical distance from the base to the opposite side, okay? This is your height. If you are given this length, this is going to be irrelevant, okay? We do not want to use that side. And a lot of times you're going to be given that side, okay? So make sure that you know what to use and what to throw out. So, for example, let's find the area of this square. Now remember also that your formulas are going to be given on that formula sheet, okay? So you're going to have those on the test. So I wouldn't devote a whole bunch of brain power to remembering these formulas. Just know where to find them if you need them. I would, again, look at that formula sheet long before the test so you know exactly what is given, what isn't given, and where to find it when you need it in a hurry. So for this example, we want to find the area of the square. Now we know that it's a square, so we know that all of our sides are equal. So we also know that this is 9 centimeters, this is 9 centimeters, and this has to be 9 centimeters, okay? Remember that our area is just our base times our height. So our base is that 9 centimeters and our height is 9 centimeters. So our area is just going to be 9 centimeters times 9 centimeters, which is going to give us 81 centimeters squared. So remember that we're going to have that square going on here. Okay. Now, this is a good place to pause and make sure that you can find this solution too. To find this area of the parallelogram, remember that we have area equals base times height. Our base is going to be that 55 millimeters. And our height, remember, is vertical, okay? So we want this, which is 24 millimeters. This 30 millimeters is irrelevant, okay? It's a red herring, if you're familiar with that from your English classes, okay? It's given, but we don't need it. We only need the base and the height. So if we get our area, it's going to be that 55 millimeters times that 24 millimeters, which is going to give us in our calculator 1320 square millimeters. Okay, so that's our area there. Now, when we move to a trapezoid, remember that we still have two opposing sides that are parallel, but the other sides are not parallel, okay? The ones that are parallel to each other are called the bases of the trapezoid, okay? So the ones that, line up against each other. They don't ever intersect, okay? Those are the bases of the trapezoid. Again, our height is that vertical distance. So if you're given either of these, it's going to be irrelevant. I can't spell. And this one would be irrelevant. Okay. It doesn't matter if they give those to you. You're not going to use it. You only care about your bases and your height. Okay. To get your area of a trapezoid, you are going to do base 1 plus base 2 and divide that sum by 2 times the height. If it helps you, if you like to think about it this way, you can think about it as this is the average of the bases. Okay. So you're going to take your average base length and multiply it by the height. That helps you think about that. If not, just remember to use the formula. So let's take a moment and practice. Again, this would be a great place to practice and pause. But let's go ahead and verify that this area is going to be 444 centimeters squared. So we have a lot of information here, okay? Remember, we don't care about what's on the slanted sides, okay? That's completely irrelevant. Mark them out, ignore them, okay? This one's going to be one base. This one's going to be another base. It doesn't matter which one's 1 and 2. You could name them opposite. And this one's going to be your height. Remember that your area is going to be base 1 plus base 2 over 2 times your height. So if we do that in our calculator, we are going to get 30.0 plus 44.0 over 2 times 12.0. These are all in centimeters, okay? I come from a scientific background where we usually sort out what our units are going to be, do the math, and then add back the units. If you want to do your units the whole way, that's fine also. Just be very careful with your handwriting. I've seen a lot of students, you know, add a 0 because it was a messy C or whatever. Okay, if we plug this into our calculator, we are going to get 444 centimeters squared. Okay. So we have centimeters times centimeters, and that's going to give us that centimeter squared. Okay, now you practice. Find the area of this trapezoid. Well, base 1, base 2, and height, because it's that vertical distance. They didn't give us the slanted here, okay? Our units are going to be centimeters times centimeters. So it's going to be centimeters squared. And our area is going to be 25 plus 42 divided by 2 times our height, which is 18. And if we plug this in, we are going to see it is about 603 centimeters squared. Okay. Make sure that you can get these. These are great test questions. They're easy if you know where to find the formula and how to use them. Okay. A lot of students do really well on this test. Now, we've talked about parallelograms, we've talked about trapezoids. Now we need to talk about triangles. When we talk about the area of a triangle, we're still talking about base and height, but now we have 1/2 times the base times the height. Okay. The height of the triangle has to be the vertical or perpendicular, if you want to talk about right angles, distance from the base to the opposite vertex. Okay. So the height is going to be that tallest vertical distance from the base to the very tippy top. Remember that when we had a parallelogram, we had, I'm going to write it here. The parallelogram area was base times height. And remember, the triangle is just half of it. So if that helps you remember, our area here is going to be 1/2 times that base times that height. So if we want to find the area of this triangle, we know this is the height. We know this is the base. So our area is going to be 1/2 times base times height, which is going to be 1/2 times, if we leave the units on here, it's going to be 20 meters times 45 meters, which if we plug into our calculator is going to be 450 meters squared. And that's our answer. Again, you could have sorted out your units first. You see meters times meters, you know you're going to be doing meters squared. Okay. So sometimes we have a special case, okay? We talk about right triangles. And remember that by definition, a right triangle has one base and one perpendicular leg, okay? Use one of your legs as the base and use the other one as your height. Problem solved, okay? Your hypotenuse is never going to be one of your, it cannot be your base, okay? Ignore the hypotenuse. So for example here, we don't care what this angle is. We could find, or what this length is. We could find it with Pythagorean theorem, right? We learned that in, what was that, section 2 here? We only care about the height and we care about the other side of it, okay? Whatever is across from that right angle, we don't care about. We only care about the other two. We're going to do 1/2 times the product of the other two. So here our area would be 1/2 times that 22 times that 37, and we get 407 centimeters squared. Okay? Give this one a try. It's a right triangle, so we know that this is a right angle. And we don't know the hypotenuse, but we don't need to. Remember that our area is going to be 1/2 times the base times the height. So that's going to be 1/2 times 15 centimeters times 25 centimeters. Which, if we plug into our calculator, 1/2 times 15 times 25 is going to be 187.5 centimeters squared. Okay? Now, pause here and make sure that you can work this out. But what's the area of this right triangle? Well, we know this is our right angle. This is our hypotenuse. We don't want the hypotenuse. We need to know what this is for our height. What do? We're going to use our Pythagorean theorem. Okay? So we know, let's make this x inches. Okay? We know that x squared plus 12 squared equals 13 squared. So that tells us that x squared equals 13 squared minus 12 squared, and that x must be the square root of 13 squared minus 12 squared. Okay, looking back at the triangle section. And if we plug this into our calculator and solve, we're going to see that this has to be 5 inches. Okay, so x is going to be 5. So now our area is just 1/2 base times height. So we're going to get 1/2 times 12 times 5, which is going to give us 30 inches squared. Okay. Make sure that you can solve this one. I also like to include these on a test. All right, so we've talked about most of the shapes now. But what about the area of a circle here? Well, the area of a circle is always going to be pi r squared. And remember here, the r is going to be the radius. Remember to use that pi button on your calculator that you have, okay? Don't just use 3.14. It's not going to get you close enough in a lot of these cases. So the area of a circle, again, you don't have to memorize, but it's going to be pi r squared. So if we want to find the area of this circle, we need pi, which is in our calculator, and we need to know r. We're given 40 centimeters. That's our diameter, okay? So our diameter is 40. So our radius is half of that, so it must be 20, okay? So our area is going to be pi times 20 centimeters squared, which if we plug into our calculator is going to give us somewhere around 1,257 centimeters squared. Okay. And there's the solution right there. Now pause for a moment. I have no idea why this showed up. It's like dragging itself. Kind of ignore this, okay? Find the area of this circle. We know that our area is pi r squared. We know pi goes into our calculator. And we know our radius here. It's not given to us as the diameter. It's given to us as just that half point. So we're going to have 5 decimeters squared. If we plug this into our calculator, remember we just leave the unit off in our calculator. We are going to get 79 square decimeters. Okay, rounding to the nearest whole number. Obviously, you'll have to round some when we're dealing with pi, because it's that whole irrational mess. Now, sometimes we want to convert units, just like we've talked about before. Okay, we can easily convert, meters to kilometers, right? But when we're talking about squared units for area, that's going to apply here even when we're squaring to the other side, okay? I personally think from your text, it's easiest to follow these examples, okay? If you want to convert centimeters squared to millimeters squared, let's say 4 of them, right? The number that you have there, and then if you have squared centimeters, centimeter times centimeter, okay? Because that's just going to be 4 times 1 times 1, so it's going to give you 4. So then those 1 centimeter and 1 centimeter are going to sort out your units. So that's going to equal 4, which we know, okay, times 10 times 10, because 1 centimeter is the same as 10 millimeters, okay, because centimeter is 10 to the negative 2, millimeters is 10 to the negative 3, and so we're going to be going down right, okay? So 1 centimeter is 10 millimeters, and another centimeter is another 10 millimeters, and if we multiply all that across, we're going to get 4 times 10 times 10, which is going to give us 400 square millimeters. So that's going to be the same thing. 4 centimeters squared here blows up to be 400 millimeters squared. Now, what about 5 square yards to inches squared? 5 again, 1 yard, 1 yard. Okay, so 1 times whatever unit times 1 times whatever unit in your original. Keep that 5, and then we know that a yard is 3 feet, and so we know it's going to be 36 inches. So 5 times that 36 inches times that 36 inches, multiply 5 times 36 times 36, and we're going to get it blown up all the way to 6480. Okay, so over 6,000. 5 yards squared is over 6,000 square inches. Okay, it blows up fast when we're talking about area, and in the next unit, it blows up even faster with volume. Okay, if we wanted to convert 6,000 square meters to kilometers, we do the same thing. 6,000 meters squared, so 6,000 times 1 times 1. And then 1 meter is 0.001 kilometers, okay, because it's 1/1000th of a kilometer. We do the same thing, and so we're going to get that 6,000 meters squared is only 0.006 kilometers squared. Okay. Let's practice this one. Convert 8 millimeters squared to centimeters squared. So we have 8 times 1 millimeter times 1 millimeter. And we're going to keep that 8 there. And remember that 1 millimeter is 10 to the negative 3, centimeter is 10 to the negative 2. So we're going to move that decimal place one way, okay? 0.1 centimeter, 0.1 centimeter. And if we multiply that across, we're going to end up with 0.08 squared centimeters. Okay. 500 meters squared. So 500 times 1 meter times 1 meter is going to be the same as 500. Remember that 1 meter is 0.001 kilometer. And if we multiply those straight across, we're going to get 0.0005 kilometers squared. Now, some of you, especially if you've taken a chemistry class, may know a slightly different way to do this. We actually talked about factor analysis or dimensional analysis in our unit analysis, I guess, in our last section here of Unit 4. If that's something that you're used to doing, go for it. It'll get you the same answers. It's effectively what we're doing here, just without stacking those units. If you have no idea what I'm talking about, just hold on. Nothing that you need to worry about yet, but we'll see some examples of it in section 6. Okay, so if we're dealing with area, sometimes we're going to have to break our shape into more easily handled shapes to get your solution, okay? Sometimes instead of looking at an ugly shape, we want to break it into pieces, just like we did with the perimeter examples, okay? So find the area of each individual region, and then add them together to get your total area. Sometimes you're going to have to think critically, and sometimes there are lots of different ways to do this. Okay, sometimes you may not do it the way that I do it, but it gives you the same answer. Maybe I broke it up differently than you would, and that's totally fine. Okay, there's a right final answer, but there's no right way to break it up. Sometimes there's an easier way to break it up, but you do you. So here, let's talk about some practice. If a counter measures 3 foot by 5 foot, we want to find how many 6-inch by 6-inch ceramic tiles it's going to take to cover the countertop. We also must buy 5% extra to allow for waste. Let's deal with the 5% after, okay? We know that our counter is 3 foot by 5 foot, okay? But we know that our tiles are 6-inch by 6-inch, okay? So I would probably, you need to go either to feet or to inches. So make your choice, okay? You can do 3 foot by 3 foot, and then each tile is 0.5 by 0.5 feet. Or you can say, well, this is going to be 36 inches by 60 inches, okay? Switching everything in inches and go that way. It's going to give you the exact same answer, okay? So let's do it that way. I don't like working with decimals if I don't have to, so doing 0.5 and 0.5 to me is more difficult. Again, test run it, do it the other way, and make sure you get the same answer. So 3 feet is 36 inches, and 5 feet is 60 inches. So the area in square inches that we have here is going to be 36 inches times 60 inches, which is going to give us 2160 square inches. Okay. Now we know that each tile has an area of 6 inches by 6 inches, which is 36 square inches. So thinking critically here, we have a total area to cover here, and each one of them is here. We can calculate 2160 square inches over 36 square inches is going to give us 60 tiles, but that's without waste. Okay. If we want to include a 5% waste, we include a 5% extra, use our concept from last unit, right? We're going to take our 60 tiles times a 5% increase, and that is going to give us that we need 63 tiles. Okay. Now you can try it another way. Try doing 3 feet by 5 feet, but our tiles are 0.5 feet by 0.5 feet. It's going to give you the same answer. Okay. If it doesn't, figure out the mistake. Let's do one more problem before we wrap up. We want to find the area of this beast. Now, there are a lot of things that you can do here, okay? In fact, the first time I did this in a class, I was like, oh, we could break it up to here, we could break it here, we could break it here, and we could break it here, and we could break it here, okay? That's a lot of work. It would work, and you have enough information to do it. You got to do some math with these triangles, right? But that's a lot of work. What's going to be easier here is to notice it's just a trapezoid. With a little cutout. So if we find the area here of this whole thing, and then we subtract this area from the total, we're good to go. That's our answer. The area of the whole trapezoid is going to be, if we look at our bases, notice that this is 5 centimeters, okay? So this whole base has to be 10 plus 5 plus 9, which is what, 24 centimeters? Okay. So if we do 10 centimeters plus 24 centimeters over 2 times that height is going to be that 7 centimeters. Okay. That is going to give us 119 centimeters squared. The area of our cutout is going to be 5 centimeters by 2 centimeters. This is going to be 10 centimeters. So the area, we can do this first, this second, and this third. The area of the shape given is going to be that 119 to that whole trapezoid minus that 10 centimeters squared, which is going to be 109 centimeters squared. Okay, if you can do this problem, you should be golden. Remember, you're going to need the formulas for what, parallelogram, trapezoid, triangle, and circle. But also remember that you're given those formulas on the formula sheet. So just know where to look and where to find them. Again, I would encourage you to go look at that formula sheet, be very familiar with it, use it for your homework. Don't make any extra notes on it because you can't have it printed out, but you will have access to it. I will include it as an attachment on your test. Okay, so remember, use those formulas that are given and be very careful with units. Make sure they're all the same. And if needed, convert it before you take the area. Okay, before you take the area, make sure that you convert. I highly encourage you to practice here. Look at the old tests, look at all those practice problems in your text, all the examples throughout the text portion. There's those review sections. There's all the extra stuff in Blackboard. Definitely get practice where you need it. If you still need more help, remember that I'm available, the Math Center is available. There's lots of resources available to help you succeed. As always, thanks for tuning in, and I will see you guys next time.